you all for joining us for today's live webinar hosted by Astrix. Today's topic is Why Do Digital Lab Initiatives Struggle? How Astrix's Lab of the Future Blueprint Turns Vision into Impact. This presentation is brought to you by Astrix, and we're excited to have you with us. Our presenter today is Max Peterson, Senior Principal Architect at Astrix, and we're looking forward to his insights. As a reminder, if you have any questions at any point during the presentation, please submit them in the chat box. We will read the questions anonymously. We won't mention your name or company, we'll just read the question. Before we dive into today's session, I'd like to start with a brief overview of who Astrix is and what we do. Max, if you could please go to the next slide. Okay, perfect. If you're joining us for the first time, we're thrilled to have you. And if you're returning from one of our previous webinars, welcome back. We appreciate your continued engagement. Astrix is a consulting firm dedicated exclusively to the life sciences. For more than 30 years, we have delivered technology and strategy consulting to organizations advancing biotech and pharmaceutical R&D. That focus is why we understand the science, the systems, and the challenges our clients face every day. We are science-based at our core. Over 90% of our teams hold advanced scientific degrees, and we were founded by scientists in 1995. We are a science-based company built to support other science-based companies. We are also technology agnostic. We do not favor any single vendor. Instead, we work across platforms to help you select and implement the solutions that genuinely fit your needs. Our loyalty is to your goals. That combination of specialized expertise, proven processes, and vendor-neutral guidance has made us a trusted partner for life sciences organizations pursuing digital transformation and scientific innovation. And now I'll hand it over to our presenter, Max Peterson, to introduce himself and begin the presentation. I'll be back on at the end for Q&A.
Yeah, thank you, Sam. It's a pleasure to talk to you today. My background is mostly on the scientific informatics vendor side. I've had various roles ranging from being an application scientist to driving implementations of platforms, doing strategic consulting for our customers. I also spent some time in a physical lab automation company, and I, for example, headed up the chemicals and materials division at Dogmatics, and I took the liberty of taking a little bit of an excursion to formulations and materials science in one of the case studies. But I believe that everything else is really broadly applicable throughout life sciences. And with that having said, I also want to point out that as a services company, Astrix, of course, has a very broad view on digital transformation initiatives, starting from the more strategic side, which we think of largely three buckets. Strategic innovation that covers things like value mapping and ROI determination, understanding the actual workflows, application roadmaps and implementation assessments, to what is really the core of what my role at Astrix is, namely looking at enterprise architecture. And one of the things that I'm going to emphasize is that our view is that there are three levels of architecture. There is the scientific architecture, which really governs how scientists interact with data, both from an operational point of view, that means how things happen in the lab, and then of course also from a data consumption point of view, namely how data has to be made available to either analytics or machine learning AI type applications. That then informs what we think of as being the data architecture, which is really about how do scientific data relate to each other, what is the contextualization of this data, and explanation, think ontologies, taxonomies, controlled vocabularies. And then lastly, and ultimately, the systems architecture. That means how are these two architectures physically implemented so they can be leveraged. And the system architecture can then lead over to solution selections. And this is kind of already at the core of what we're trying to explore in this presentation, is that a lot has to happen before one can successfully choose an appropriate vendor, if that is needed at all. But from that point of view, success is really dictated by these upstream activities. And then, of course, Astrix has a broad view on what happens after the selection, namely deployment, validation, support, and sourcing. And all of that gives us a broad basis of understanding success criteria for digital infrastructure. And it also generally boils down to very simple terms. Yeah. First of all, similar challenges like data compliance, fragmentation, change can lead to very different outcomes. And what we observed is that decisions that are made locally often create constraints at scale. So this is tied to this issue that many successful POCs fail to implement and to scale. Early architectural choices limit future flexibility. That means that what works for one pocket of the organization may not be applicable broadly. Data and workflow decisions are often made without a unifying model, and change management is treated as an afterthought. That means after all your data infrastructure is set up, somebody comes in with the idea to say, well, now we need to make sure that the life cycle of these data constructs are managed consistently and successfully throughout the life cycle of the application or the platform or whatever infrastructure is being put in place. So the key idea here and the takeaway is that success is not driven by any single decision. It's driven how decisions are made and connected. And the blueprint is fundamentally a response to this. It's not a prescriptive one-size-fits-all set of instructions, but it's a structured way to guide complex interdependent decisions. And just to give you a flavor of the minefield that we can enter, if we're thinking about systems, processes, people, here is a list for each of these categories that can fundamentally guide in which direction the digitalization journey can go, right? So just some highlights. On the process side, we already touched on data governance. We touched on ontologies and taxonomies, how AI can be responsibly and compliantly be deployed, how SOPs can be digitalized. Then on the system side, you have, of course, systems, LEM, CLN, LES, but more importantly, everything around surrounding them. Yeah, data platforms, data harmonization, metadata contextualization, workflow enablement, IT/OT convergence, and instrument data integration. And last but not least, on the people side, we have change management, organizational alignment, an incredibly important topic. We have the role of IT versus business. We have sponsorship, adoption, collaboration, and data literacy. So each of these decisions can be a point of failure, and a blueprint is really designed to provide some path through this decision obstacle course. So that having said, the blueprint is not a template, it's an execution model, where a template mindset is really about being static, prescriptive, tool-driven, and thinking about local optimization, whereas the blueprint mindset is about being adaptive, guided, workflow-driven as opposed to tool-driven, and thinking about enterprise scalability as opposed to local optimization. So this is what I mentioned verbally at the beginning, that we think about architecture of these three interlocking gears: the scientific architecture, which thinks about quality, manufacturing, processes, domain knowledge, and scientific workflows. And data architecture is really the mapping of what happens during these activities from a data perspective, and how data needs to be organized and provisioned to support these business processes. Only then we can think about how does this map on a systems architecture, because the systems architecture needs to support the data architecture. And this is a really key observation here, that in many cases, these processes happen in reverse. We think about needing an ELN. We then try to configure the data architecture that can then ultimately support workflows, whereas the process should be done in reverse. And this is really summarized here. It's about a deep understanding of the current state and the specific challenges of use cases, and then followed by an assessment of the data requirements, the future state, combining updates to data and business processes, and then ultimately this leading to an evaluation of multiple systems and how they can interact to provide a comprehensive solution. So ultimately, we can think of the blueprint as a transformation engine. Our inputs are fragmented workflows and processes, disconnected data and system landscapes, undefined or evolving business objectives, organizational constraints, things like compliance and change readiness, and existing technology investments in legacy decisions. So this is an important point, that none of these systems operate in the vacuum. There's very rarely a situation where a system can be put into a greenfield situation. There's always existing operational data that is being utilized, and we need to wave the new technology and data constructs into this existing framework. So the blueprint ultimately boils down to a guided decision frameworks, proven patterns and experience, and creates an alignment across workflows, data architecture, and governance, and converts complexity into structured, scalable decisions. So the output of this engine should be an aligned future state architecture that is really, think of it as a North Star where the journey should be going, the prioritized roadmap and the program structure, which is the map of how to get to that North Star, a view of integrated data and workflow models. This is, of course, now tightly linked to the future state of working. And for that, of course, we need a governance and operating model and solutions that are designed to scale beyond the pilot. So on that strategic side, we are really following 4 discrete steps, visions and business drivers. This is really a key alignment point with the businesses that can and must define where the journey has to go, and also what a successful outcome of a strategic digital transformation project should be. Then, very importantly, confirm the business and data capabilities. This is the mapping of the as-is states, but then from there, looking at what business needs are, which creates either what we think of as a heat map, what me as an architect thinks more as a logical architecture. That means what capabilities are really needed in order to support the business operations. And this can then be mapped onto the future state high-level architecture. That means, for example, an architecture in terms of data architecture. That means how entities are interrelated, how data flows between different systems, and how users actually operate in a before and after scenario with the as-is and the future state. And this then leads to a transition strategy that basically organizes the activities around different core objectives like scientific workflow enablement, data automation, improved planning, support of innovation processes, change management, and then, of course, into a phased implementation plan that aligns these different activities in a way that can maximize the impact, meaning finding the ideal touch points, implementing the most high impact use cases first, while at the same time working within the constraints of the systems and the rollouts. Here's just a flavor of how, for example, one of these business and data capabilities outputs looks like. Yeah, we basically have lab systems and capabilities that are required to get work done. The existing systems that are supposed to use and support these processes. And we can then score whether a system fully supports any of these capabilities or doesn't address them at all. And this then just visually gives you an idea of where you need to focus your effort to resolve certain capabilities. And this can then be contrasted, for example, with pain points, where we basically understand where the biggest bottlenecks in the current state are in terms of business workflow support, and map this onto a systems inventory. And then last but not least, arrive in a situation where we can score how the existing current state, but also, for example, vendors or technologies or whatever the end goal of a digital transformation program is, to basically give you a very clear way of driving decisions in a structured manner. So in terms of high-level architectures of a future state, we work with a lot of organizations that are looking at centralizing data to provide a unified or harmonized results access. And this is really driven by the data consumption layer, where we have, of course, interactive and ad hoc visualization, reporting, analytics, AI, ML. They all rely not only on access to raw data, but contextualized and harmonized data. That's, of course, where reference and master data come into play, ontology management and data quality tools that can either be applied at the master data level or also on the data orchestration and data ingestion level that is responsible for building a bridge between the operational systems and the data transformation layer that provides the harmonized result storage. Here's another view on the roadmap that I already mentioned. And here we see a strategic roadmap organized by themes that lists goals and recommendations for a clear alignment of these work streams onto a strategic roadmap that is here now formulated in terms of timelines. And I also want to point out that in terms of overall execution, we really only touched on the strategic direction assessment and the technology selection, workflow and project planning phase. And that basically the whole reason for spending the time and effort to mapping out a strategic plan is really to ensure success downstream from these activities. Think of these activities as almost a prerequisite for a successful program, whether it is a large-scale ELN replacement or a new set of tools that need to be rolled out organizationally wide. This is a really key foundational aspect that can define and ensure result downstream. With that having said, I would like to cover some representative case studies. So I have picked 3 of them. The first one is an end-to-end program that really talks about large-scale digital transformation. In terms of our 3 gears here, this is really showing how all of these 3 gears engage into each other. The next one is about formulations data management. I already mentioned in the beginning that I'm going to talk about that. And this is really about more capturing the scientific architecture and creating the alignment along these functional boundaries. And then we're going to talk a little bit about how that then leads to breaking down silos via an architectural assessment study. So This large digital transformation program is really a long-ranging program that started out by looking at how to modernize not only the digital infrastructure, but how R&D is carried out in a data-driven decision-making and operational efficiency framework. And the challenges were really data silos that can't really go to data-driven R&D if your information is scattered across systems and is incredibly difficult to curate. And it's also indicative of this excessive amount of manual work. How scientists spend excessive time on data entry and reporting, over dependence on wet experiments, a lack of predictive modeling, and inconsistent data practices, which lead to limited data reuse and comparison. So this all started out in exactly the framework as we discussed, really focusing on these key points here: structured data capture, centralization of information, automation of reporting, predictive analytics, integrations of systems, namely ELN, LIMS, inventory solutions unified on a single platform, and an operational playbook, a target operating model that ensures consistency and sustainability for the entire life cycle. So as of today, we have 60 workflows that are being adopted by R&D, also an end-to-end request management system. We've seen significant efficiency gains in terms of reducing manual work, faster decisions with real-time data. We've seen improvements in data quality and reuse, and a broad engagement. And I just wanted to give a flavor of what a digital transformation playbook may look like, aligned on these three pillars of scientific architecture, data architecture, and systems architecture, where the scientific architecture really is about proposing scientific business use cases, objectives, groups involved, descriptions, usage patterns, inputs, outputs, mapping of current state workflows and data. What are the bottlenecks? What are the system limitations? What are the manual workarounds that are in place? What are the hands-offs and collaboration? And then the quantification of the pain points and impact potential, cost value, data quality impacts, efficiency, productivity. This is really to gauge and prioritize what needs to be done next. Then we have a business-driven gating process that then transfers this to the IT side, where then the data architecture and subsequently data systems architecture is devolved. So this follows the analysis of the impact and design of the future state workflow. This includes things of impact analysis, workflow mock-ups, design and specifications that can be then taken back to the businesses to gauge that everything is well aligned. Then comes the architecting part of the data architecture. So this is basically development of the data model and ontology. And then a confirmation with the SMEs. That is validation, and that's where these workflow mock-ups come into play. And then there's an IT-driven gating process that then allows us to map this into the systems architecture. we're basically building out the reference architecture and that all future data management needs are supported, gaps in existing systems and platforms, and then a recommendation of systems and platforms for implementation. Then there's a steering committee-driven gating process that then leads to implementation and solution lifecycle management. So in terms of formulation data development, this is really about creating a consistent access to a singular trusted data across multiple operational processes and systems, standardization of materials, and unification of workflows and information flows across the R&D lifecycle. Yeah, challenges are also quite typical: legacy systems with overlapping views, uncoordinating overlapping digital initiatives, complex and manual end-to-end workflows, and inconsistent and redundant systems architecture. What did we achieve? Organizational alignment to the identification of key use cases, systems, data flow, and standards, end-to-end visibility, and an IT landscape simplification. And I just wanted to put this up to give people an idea of, from a functional architecture point of view, that there is quite a number of areas that need to interface and interoperate. Things like the material lifecycle, regional support, product components, analytical characterization, testing, claim support, annotation of hierarchical annotation of materials, and formulation analytical lab digitalization to support the lab back end of things. And I'm also thinking of this as a separate case study because it really talks more about how do you engage in this in terms of managing consistent access to data. And on the left, we see the as-is state, or as it was at the beginning of the project, namely that central systems like LIMS, ELN become hubs for point-to-point integrations. And then there are other hubs, like, for example, product development databases that connect to raw material information, to the claims database. And these type of point-to-point integration scenarios, they become really unsustainable as infrastructure may need to be modernized, new use cases or applications, business processes need to be supported. And our solution was really to build a connecting data hub that can push data to a data lake and to an analytics layer, and really ingest data from the more operational systems or peripheral systems like an ERP, and pull and push data back and forth between analytics and operational systems. So the centralized data hub is really about replacing point-to-point connections, but it also provides a single point for ingesting and processing data and connecting it and moving data around, and provides a mechanism for connecting and or ingesting internal and external data sources. And the important part is that once you embark into that journey, you need to align this with data governance, because obviously now we are having to deal with data contracts that determine how data are exchanged between these systems. And these will be evolving as the business needs evolve. And really, these things need to be happening in parallel to basically provide a framework to manage how data models are published and basically administrating the single source of truth, and provide single business definitions of entities and attributes. It's extremely important. So with that having said, coming to the end of this presentation, so at a very high level, we really think a blueprint approach is really critical and almost mandatory. And what this blueprint approach provides is a guideline how transformation are designed and executed, and avoiding decisions being made in isolation. And namely, what needs to happen is that these need to be coordinated and done at a system level, and whether workflows, data architecture, and governance are aligned from the start. And the blueprint is really not a technology-first solution or a data model in isolation or a workflow standardization exercise or a vendor selection shortlist. And really, digital transformation succeeds when it's treated as an integrated system and not as a set of projects. And with that, I would like to thank everybody for their attention so far. And I'm going to hand it back over to Sam.